Hey folks, I guess we're just going to go ahead and get started here without further ado. Um, Welcome to another episode of the Common Lisp Virtual Study Group. This is Ron Badum from Atlanta Functional Programming. Today we'll be continuing our discussion on our sort of case study sample project written for Common Lisp, specifically a example file transfer server that leverages a couple of libraries, particularly CL PPCRE for regular expressions, usocket for socket programming, and bordeaux-threads, which is a cross-Lisp multi-threading library. Depending upon which threads you leverage, which implementation you leverage, how it maps to that threading implementation for each Lisp is going to be slightly different, but it gives you all the primitives that you would normally expect in a threading library for creating multi-threaded applications. Last week, I've already sort of briefed you on the project structure. To quickly review, if you recall, give me just 1 second so I can share my screen with other folks here. Just a quick review here. If we look at our AFP FTS system definition here, we just have a very simple project definition that I leveraged using Quick Project. The actual directory structure, if you guys would like to see, is basically what you would normally expect in a standard project nowadays. One of the differences, of course, being that I've already hooked this into the Travis for continuous integration and for testing. We have a separate test directory, of course, that lists where our unit tests would be. We're leveraging a library called Prove that was created by Eiichiro Fukumachi. Just to give you a little bit of a review of what this does is right now our test cases that we've written is basically a simple plan that will connect to a server, check to make sure that the server thread is alive, try to create a client socket in the main thread to try and check to see if we can connect, and if we can, go ahead and exit out of the connection and go ahead and make sure that the thread actually died. Now today we're extending this so that it can take in multiple connections, and it won't actually technically die once a client says quit. Instead, the server will just keep waiting for additional connections until you actually kill the server. When you're dealing with multiple connections in a traditional multi-threaded application, normally you would try and set up your thread pool. At least this is how I normally design these multi-threaded applications. I set up a thread pool and create essentially a queue where incoming socket objects will get thrown into, so that these threads, which are asleep, will wake up, grab the next incoming connection, and work with it until obviously that client quits. When you do this in systems languages like C or C++, normally you would use a pattern that's called a producer-consumer pattern, or another way of saying is boss-worker, where the boss delegates the work to each of the individual workers by putting it on a task queue and saying, okay, whoever's available, go ahead and do this work. Hello? Hey, Judd, could you please mute your microphone? Thanks. um, boss in a boss worker, you would normally, just have the user, the boss, go in and add work to this queue, and then whoever's available will pick it off the queue, do the work, and then just move on. How we normally do this in a traditional multi-threading library, I mean, in any other language that supports concurrency with threads, is you'd use a condition variable, and you would sleep all your threads in your worker thread pool on one condition variable, and you would have another condition variable that would essentially put the boss to sleep if the work queue is or producer queue is the queue is actually full, and workers still need to pick off items from the queue so that the queue can be slightly less full, so you can add more work to it. To show how this can be implemented, I created a primitive implementation of this. Obviously, this can be cleaned up, and while working on this, I had realized that there's some points of discussion that, while we talked about a little bit last week regarding thread local storage, we haven't really discussed, what is actually kind of like the best ways of dealing with creating these variables for different threads, especially if you're creating something like this. So this is what I came up with as a starting point for discussion today. So let's go through the initial implementation that I come up with, and I will open up the table to discuss, ideas on how one could possibly clean this up, or if there are other implementations that could be done to actually implement the same idea. Are we all on the same page? Cool. So this is a very simple extension to what we had last week. What I did is originally last week we started with this function here, which is our start server function. It took a host and a port, and what it did is it created a thread that would grab that host and port and create a ServerSocket. This ServerSocket would listen on that host and port, and it would originally accept sockets, do whatever they needed to do internally in this main thread until it quits, and then subsequently started waiting for new connections. Now, what you may have noticed, for those of you who started on this project, and those who want to actually look at the code right now, you can download this over at https://rbatum/afd.fts. And one person mentioned that I'm going to post this GitHub URL in the video notes for later reference, so that you guys can actually look into the video if you've forgotten this URL after the stream. Instead of doing the socket handling all in a single thread of execution, what I did is I created a thread pool that right now only is one thread, but we could certainly make this more than one. Originally, I had it that you would want to use the number of normally you'd want to use the number of cores that you have on your system plus one, so that you have full utilization of all the cores. Right now, there is one thing that I noticed when I was reading the bordeaux-threads library, and along with some resources related to doing threads with the Common Lisp cookbook. And one thing that is kind of missing in bordeaux-threads is the ability to see actually how many system threads are available. Now, the Common Lisp cookbook worked around this by creating a separate C program to grab the number of cores that are available and the maximum number of threads that one could actually run. I didn't have a chance to actually move that code into a C program to get the number of threads. But hopefully I would, after we're done with this today, what I will do is I'll grab that code, put it into a separate executable, and make sure that this program will leverage that when it's creating the thread pool. But let's look at how this thread pool is created for the time being. I'm going to change that to 3 so that makes it more realistic here. So what our thread pool function does is all it does is it loops through the number of threads that we want to create, and for each one it creates essentially a closure that binds standard output to std out. We saw this last week. This is how one way one would be able to pass arguments to a thread when it needs to actually do some work. This worker thread name stream is primarily so that we can name the thread and look at that all the threads have been created by the diagnostic utilities I showed last week. And when we run this program again, you'll see that as such. What does this thread now do? This thread basically did what we essentially did last week, which is originally, if it's not getting a file, it will act like an echo server, and it will print out whatever the user sends, and it'll print it out to particularly our server console in the REPL. But if the user grabs information, this will or particularly it requests that a file to be downloaded, this will go ahead and open up the file and just spit it out to the socket. I treat these as character streams. I'm not dealing with binary data right now. This is one thing that could be an exercise in extending this, and it's really not that difficult to add to extend this to leverage binary data. But this is the main code here. Originally, and this is sort of a standard approach to actually dealing with threads in any language. You check to see if you grab the mutex, which we created originally in this script by making the call to bt makelock. Bt makelock makes actually a mutual exclusion variable. It maps it, if I recall, on both Mac and Linux to pthreads mutex t. And on Windows, I'm forgetting right now what SBCL does and what CCL does. It's kind of similar, but it matches it to its system threads library to grab those mutual exclusion primitives. And you notice here that I have these two condition variables that we created with make condition. Now, the first thing most people coming from other languages and who have actually dealt with threads in other languages may have noticed is these names. Normally, you won't be dealing with named mutexes. You might be dealing with semaphores that are named, but not mutexes and condition variables. At least I've never had in production code. But this naming is particularly useful when you're debugging in the REPL. And we'll see why, because you can actually see with the diagnostic utilities provided by bordeaux-threads what threads are waiting on what mutex, which is kind of useful for debugging. It really helped me, at least, while I was debugging this program. Next, we have our shared queue, which will hold our tasks. So what this client does is it grabs the mutex, okay, checks to see if we're still running, all right, and then checks to see if we have any tasks in the queue. If the queue is empty, it will do what's called a condition wait. It will actually sleep on that mutex, and while it's sleeping, while it's waiting, the mutex is actually released back to the parent or whoever it wants to make a check next. When it gets actually woken up, and we'll see later on in the server thread, and I'll show you a specific variable where it happens in the server thread, it will go in and then check the queue again, okay, exit out of the critical section, and then it will pop the first item off the queue. It will dequeue the first item off the queue, and it will handle that connection. Now you may have noticed here, this is probably something a little bit weird, but since I'm using a list, push and pop are available, but push and pop obviously treat the list like a stack. And I'm trying to treat the list like a queue. This is one way of actually making it treat like a queue. So you grab the essentially the last element of the list, which is actually a con cell. Grab the first element of that con cell, which will be the socket object, and then you reset the list to be everything but that socket object, and you move on. After we grab the list, after we grab a connection off the list, we essentially notify the producer, that is our boss, that we've taken a connection off the list. Check to see if there are any other incoming connections. I'll go handle this client and see what he wants me to do. And it goes into this loop. All right, so this is all pretty straightforward here. A couple of things to pay attention to is first this pattern right here, with this wait, woken up, and checking things out of the queue. Particularly, if you're coming from other languages, until recently, you didn't have sort of this with guard to actually grab a resource and then release it automatically. Normally, those other a lot of other languages with at least pre-C++ 11, at least I can tell you this was a requirement. You do a mutex acquired lock, and then you do a conduit using pthreads, and then you do a release lock. So you have to actually when you're in a critical section, you have to make sure you acquire the lock and you release the lock, and you call those two functions. Otherwise, you can have some pretty nasty bugs in your multi-threaded code. But with this kind of guard, with this with guard, which is now available in a lot of recent languages, you don't have to do that. And that's one particularly nice feature of this library. Now the rest of this I don't think I need to actually explain on this, but I'll go ahead and do it anyway. We grab this read line usocket stream con, like I mentioned last week. Basically, the connection that comes in from socket accept in the usocket library is what is actually a socket object. So it hides the socket descriptor and some additional information, and it has a stream version constructed inside that socket object. So that you can use the normal Lisp libraries that you would normally use to deal with streams to act on sockets as well. So it's the same API that we normally use with streams, but it's writing to a socket instead of your standard input and output stream. Once we receive the line from the socket, then this is probably kind of hokey, but what I did is I split the words on the line, check to see if he's trying to get a file, which is what this code here is doing. And if we're actually trying to get a file, we know that the second argument is going to be a file path, and what that does is this send file that I may have shown earlier. All it does is it opens up the file, loops through the file, and it spits it out directly into the socket and sends the data as is. Since we're dealing with only character data, this is not a big deal, and it makes it easy for you to use command line utilities like netcat to actually go and grab the stream and then pipe it out to a file too as well. And we'll see an example of that when we run this. When we're done sending the file, of course, we have to close the socket here. This is something I found kind of interesting about loop, and maybe there was something that I must have missed. But the only way to actually, the finally code doesn't actually run if you call return inside of a loop. Like that is, if you're trying to break out of the loop, the finally code doesn't actually run. I thought I was a little surprised by that, but I think it's because I forgot how finally actually works. I think it's after the condition stops. Like if it hits any of the stopping conditions in loops, only then will finally get executed. But if you try to break out of the loop, finally doesn't get executed. And I wanted to start with that for the discussion. Elijah, do you have any thoughts on that?
Can you guys hear me?
Hello?
Can you guys hear me?
I can, but albeit a little soft. Is there any way that you can increase the mic?
I'm trying not to talk too loudly right now, unfortunately.
Oh, okay.
Not much I can really do about it.
Okay, that's fine. You're in a hotel room, so I understand.
Yeah, not much I can do. But so there are actually even some loop conditions that can bypass finally. For example, always and never, which are the equivalent of while and unless, I think, unless the opposite of while.
You mean when and unless?
No, while.
Okay.
And while and until. Yeah.
While and until. Gotcha.
I think it's. I forget. I can never remember what the opposite, what the version that does. When it becomes. I think it's until. Yeah. So while and until. Right. Those will run the finally block. But there are actually variation on those, which are called always and never, which actually will skip the finally block entirely. They can do the same thing otherwise, but they abort the loop. And the thing is that doing a return also aborts the loop, and so it hops you all the way out.
Okay, so
with where loop defines the anonymous block, so that return is jumping out to. If you macro expand the loop, you'll see that the block is defined at the outermost level.
Gotcha. Okay, so I guess, the bottom line is and this is what I was trying to get at, is if you're trying to if you're abruptly breaking out of a loop, at least right now, if you're using the loop mini language, I don't know of any other cleaner way unless you manually deal with cleaning up your resources, because the loop mini language, at least as far as I know, and at least if I'm understanding Elijah correctly, it won't actually explicitly call out the finally if you have a finally.
It will not call out the finally.
Yes.
I actually wouldn't have used finally quite like that, personally. I would have moved that into an unwind protect. Have we covered unwind protect at all?
We not in as much detail, but you do see that I do use unwind protect here.
Oh yeah, so you do. I would have moved the socket close into an unwind protect unless you have a particularly good reason that you want that socket to remain open if an error gets thrown. Because right now, the way you have that code structured, if an error gets thrown somewhere in the middle over there, that socket will remain open.
Right. I haven't actually handled a lot of I didn't write the error handling for this code.
My point is that even without thinking about error handling or anything like that, a simple way of moving the cleanup logic outside of the loop so it always gets run is just moving it into a wrapping unwind protect.
Okay, so I wrapped it in unwind protect, and you're saying that I go
yeah,
through.
wrap loop in the unwind protect, and then move the finally code. Just that inner loop, the later loop there.
Gotcha. Give me just one second. I'm going to make a note of this so that folks can see this. This guy needs to be in actually an unwind protect here because this is a different loop. And what I'll do is I'll take this guy out and this guy out.
You do still want that return there, I'm assuming. So you do want to exit the loop early.
That's right. That's correct. Sorry about that. Yes, that's right. Okay. This guy is what I want to take, this finally piece out. Yeah. Okay. And you're saying that now that I'm outside the loop, I'm in the unwind protect.
Right. Yeah, and remove that finally keyword. At least there's no reading for it to do that.
Got it.
And just reindent.
Yeah, got to make sure that everything's nice and clean. All right, that's good.
Yeah.
I think that's right. That should work. That's what you're saying.
Yeah, that looks right to me at least.
Okay, great. All right. So the unwind protect always has code that you want to run, and we did review this.
Oh, actually, one other little style thing. You don't need that prog-n. The unwind protect has an implicit prog-n automatically.
Oh, really? Okay, that I didn't remember. Okay.
Yes.
So this guy's gone. All right. So folks who have been following along, if you recall, unwind protect actually does run through your some code no matter what. That so you'd want to, if you want certain pieces of code to always run after a block is run, you'd want to wrap it around and unwind protect, and then run your code inside of it. I'd forgotten that I'd have to move some of that code out. So this is what you would want your code to look like, so that when you're especially dealing with resource management, and you might have a possibility of a abruption in a loop, and you're dealing with the resource, those resources will get cleaned up appropriately. So that way you don't have any resource leaks. Once we do this, you may have noticed another pattern here. I have multiple with lock holds. A pattern, this actually comes from at least my experience with concurrency programming and some of the patterns I've learned while doing multi-threads. Primarily, you want to keep your critical sections as small as possible, so that way you no critical section will really be blocking others. This is normally really when you're dealing with code like this, where you're pushing work off to threads to do, and then you want to be able to continue being able to send work to them as it comes along. This is not what you would normally do if you're doing like fire and forget future style programming, where you want to just get something and then hopefully whenever it gets done it will return some sort of result. That's a different pattern, and I'm trying to come up with a decent example with that, but I haven't been able to come up with yet. This is but this is what you would normally do when you're handling connections coming in, or when you're dealing with networks. At least this is how I've been doing these. So let's see how this actually works. Oh, correct. That's right. I have it open. Give me a second here.
Hey, Ron?
Yes.
Ron?
Yes, can you hear me?
Yeah, hi. Quick question. Would it be, not saying that you need to do it now, but would it be, like, better style, instead of doing the unwind protect directly in there, to, like, break that kind of stuff out into, like, a with socket connection macro that basically does that stuff? That way you could just wrap, like, that whole section, like, when you're doing socket critical stuff into that, you know, like, with open file, so that way it closes the socket connection for you at the end.
Yes.
Yeah, and you might want to do that, actually, and there may actually even be an operation in usocket that will close a socket at the block. I don't remember offhand.
So if you use with ServerSocket or with client socket, you do get that. But I didn't see.
I think would do that actually.
I didn't see anything of the sort when you do. So what I was going to say is I didn't see anything of the sort when you normally use. So the with sockets are available that I've seen. Oh, we could possibly use with connected socket.
Let's try that. One thing though is it still does the logging as well, and so the built-in with connected socket wouldn't do a not as opposed to the set. Yeah, go ahead and give some example, give some like fake, thing there and macro expand it. Let's see what that generates.
Okay, I can macro expand this. Give me a second.
And that's fine doing that, but in the future, I would recommend that you learn blind key binding for macro expansion.
I think I have to first change this code. Let me change this code, and then we'll do a macro expansion on this.
One thing that's nice is that once the macro expansion buffer has come up, you can do further expansions inside of there. So if you do like a macro expand 1, it'll pop up the buffer, and then you can, macro expand something inside of that. Which was you're not going to explore how macro expansion is.
usocket with connected socket. I guess I will change this to stock. And we wouldn't need this anymore.
Oh, and if you really want the style of buffing up that variable, send file line also references the original one.
Excuse me, I didn't hear that.
Your send file line references the original variable, and just you were swapping them out.
My send file line will be a variable.
No, go down one line.
Oh yeah, I got it. Yeah, I see it. Let me see it. Yeah, there we go. That's right. All right. So let me see what this guy does. Control C meta M. Oh wait, that's wrong.
On the open thread.
It's line macro expand. I keep forgetting.
On the open thread.
What? I thought it was Control C meta M.
You need to run it on the open thread.
Oh, on the open paren. Okay, got it. That's what I was looking for. Give me a second here. Let me clean up this guy. So this is exactly what we're expecting. Okay.
Do you know the binding for macro expand 1?
No, I do not.
Go ahead and head back into your other buffer. And do I don't remember the command.
Expand 1. You want 1?
Yeah, that. Oh. Or just fly macro expand. Sorry. Really? That isn't a.
You need a P.
Macro expand. Ah, thank you. All right.
Yeah, I'm so used to having a computer up. I'm sorry, and I don't have my laptop with me.
So the first expansion, what it does is it essentially wraps.
One last thing, can you do a describe function on that whatever command you just ran?
On slime macro expand? Okay.
Yeah. It doesn't tell you what the key binding is. That's annoying.
Normally, if there was a key binding, Elijah, the mini buffer will tell me.
I think for key bindings, right? It's like control HK or something, isn't it?
Yes.
Yeah,
Control.
Yeah, that would let you find out what a key binding does. Yeah.
So control.
No, but there's a reverse one where you go to the function. I think it tells you the key binding, isn't there?
Yeah, there is.
Yeah.
Control HF, I think.
That's describe function.
That is describe function. Never mind.
That's what I just ran.
Yeah. Yeah, I will. I normally have my slime cheat sheet right next to me, but unfortunately.
That's all right. My point about that was more so that if you have the macro expand 1, you can then go over into the macro expansion buffer and keep rerunning that on subform, so you can expand just the bits you care about.
Right.
And avoid the noise of a full macro expand all.
Okay, I see. But let's go look at macro expand. Let me macro expand on this guy again. And as you can see, it actually does generate a proper unwind protect. It checks to see if we have a socket, goes through our loop, pops off, and then checks to see again if at some point we close the resource. If we didn't, it will actually run socket close. I noticed in the full macro expansion that what that actually converts to. But this the with the map conditions is an interesting one. I didn't know what this guy was.
Yeah, go ahead and go down to that subform and then expand that. Yeah. Also, yeah.
Okay, this is handling of the conditions that might get shot out of usocket itself on that resource.
Oh yeah, I see.
So if I wanted to do this, though, that's interesting. Because in some cases, I may end up using handler case, and if there are specific errors, I'd like to log them. And that's what I was going to add to this. I'm showing you guys the skeleton of this code without error handling, primarily so you can see how the different libraries are working together, specifically bordeaux-threads with usocket. Although I've forgotten about this usocket with connected socket. So that's a good call, Michael Gargano. That's excellent. It's available, but you could easily have written it yourself, as you can see. So, but yeah, it's interesting. So let's go ahead and run this sucker. All right. So if you guys recall from last week, my interface is really just a start server function that will actually just start the server and run the threads. And you'll notice that when we run this guy, 3 workers start up, check to see if the queue's in, and they start waiting on the condition variable. What I'll do is I'll open up a shell here, and we'll call essentially netcat on this guy, because one of the nice things about using sockets, of course, as you guys know, is you can use a lot of the basic command line utilities to test a server, unless you're like, writing like an HTTP server, at which point you'd probably want to just use like wget curl. But for here, we're just going to go ahead and use netcat. And what I'm going to do is I'm just going to show you first off our earlier example from last week. You see that, when I connect to the server, that everything will work fine. It still acts like a normal, echo server if we're just passing in, random nonsense to it. Interesting. It should have said receive. How are you? Let's see what happens there. Weird. That didn't look right. But what we can also do is we can also, let's say, grab a file from the internet, from our file system, and send it across to somebody. To show you an example of this, I have written a dummy file earlier. Just, writes hello from list 10 times. And what I'm going to do is I'm going to ask for this file and write it to a different file using that cat here. And I'm going to write it to test3. Right. So if you see now, if we do a simple diff, you will see, there's no difference, and obviously that's true because when we run test3, test and test3 both match. This obviously is a contrived example. I didn't add, like I said, error handling in here with handler bind, dealing with some of the cases. Obviously, when we're growing our program, we need to increase our tests inside Travis. Unfortunately, my time was limited last week, so I was unable to actually finish this piece of the puzzle. But the core of the code is there for you guys to experiment with adding additional features to this and running tests against it inside Travis. One final thing I want to bring up is a couple of things that we were discussing last week on TCP and UDP. This is going to become a somewhat of a different example, but it is something that would spawn discussion, which is usocket does actually support UDP quite well. The problem that we had before is normally you'd see with connected socket or with client socket leveraging a TCP socket, and you would use socket stream. With usocket, I don't believe you can use socket stream based on, with UDP, I don't believe you could use socket stream specifically because the data type on the socket would be datagram, and internally the usocket library does something specific for datagrams. For those functions, you would use something like socket send and socket receive. Both are available inside the usocket library, and in coming weeks, I'll screw up an example for that illustrates this. But I wanted to bring it up because we were having some discussion about this last week as to what support was there available inside the usocket library regarding UDP and dealing with UDP specifically. And I just wanted to at least mention that's there.
Yeah, just curious about that actually.
Mm-hmm.
Did you try doing a socket stream where the element type was unsigned by case?
Not recently. I can certainly try it now.
I might do this myself later with just like with like for UDP connection, getting a socket stream where you're getting it's a byte stream instead of a character stream.
Okay.
So that might actually work more effectively. And then what you could do is you can pull out a library called FlexiStream, which would let you do the decoding, add a decoding layer. It wraps a socket, it wraps a stream. It lets you wrap a byte stream and do a decoding and translate it into a character stream.
Interesting. I was actually thinking of creating an extension to like standard output stream using trivial gray streams to essentially wrap UDP into that, so that way it will look like a stream to most folks, but internally it's sending datagrams. But
yeah, I wouldn't be surprised if basically using a byte stream instead of a character stream would allow you to effectively do that, and then just using FlexiStream to do the decoding into whatever character that you want.
I think we're essentially talking about the same idea. I think FlexiStream is a successor. A lot of folks are mentioning that. I realized when I was looking at gray streams to leverage FlexiStream.
FlexiStream is a library that uses gray streams.
Yeah, I know, and they say that it has a few more features that trivial gray streams
No, they're actually entirely orthogonal. Trivial gray stream is a portability layer for using gray streams on multiple implementations.
Okay.
FlexiStream is a tool for doing translation of a byte stream into a character stream. That's really all FlexiStream is good for. It takes a byte stream and wraps it in a character stream.
Interesting.
Hello?
Okay. No, I'm looking. When you brought it up, I'm just looking at it just to make sure I didn't misunderstood what others were saying about it.
FlexiStream basically it does encoding and decoding based on whatever characters that you want it to.
Okay, yeah, this is Edie White's library. I'm thinking of something else. There's another streams library that leverages this guy that I was looking at. Okay. All right. I'm just going to go ahead and again for those of you who are listening on us, we were talking about streams. Yeah, there are multiple ways to obviously extend the libraries that are available, especially if you want to integrate it and leverage the standard Lisp functions, which handle streams quite well. There's ways for you to create a stream object that will integrate and will allow you to leverage the standard functions accordingly. You just have to write a function and potentially maybe an object that wraps that piece of functionality into a stream so that you could leverage it. In this case, what we were talking about is specifically the fact that datagrams, at least from my reading of the usocket documentation, doesn't seem to have a stream equivalent, but one can easily make one by leveraging the libraries that are available to create stream objects and extend stream objects that are available. So you can use those. So I'm going to pose a question. I wanted to hear the discussion, on it, which is there a better way to actually improve on this? Like, clean it up a little bit, make it a little bit more straightforward. Obviously, we did some nice things with connected socket. I'm sorry, did somebody have a question?
No, L-Parallel. It's a library. Have you heard of it? I think it's probably come up once or twice before.
Yes, and I'm guessing you're going to suggest you leverage L-Parallel.
Yep.
Okay, yes, I knew that you're going to suggest that, and I thought about it too. I wanted to show the low-level piece to see if other people would come to the connection, the same conclusion. And yes, folks, L-Parallel is certainly a way to improve on this. How?
Yeah, because L-Parallel provides thread pooled and safe keys.
Yeah, it provides a lot of interesting features, and this will lead us to a new discussion. So I thought I would at least bring up a very quick and see how well I can actually show this off without having to write significant code, which is some simple examples on the REPL of L-Parallel. So L-Parallel is a library that gives you a lot of different concurrency primitives as well as some high performance primitives. It's available via Quick Lisp too as well. So to install it and load it, obviously you'd want to run L-Parallel. And L-Parallel's library is quite extensive, so I don't think we'll be able to complete everything. As you can see here, there are multiple namespaces here to actually go through. But
hey, Rom.
Yes.
I'm sorry. Just before we get off onto another thread library, can I ask 2 questions?
Yeah, sure.
So I know you mentioned last week about thread local, and I know you mentioned it in the beginning of the talk today. I was a little preoccupied for the first few minutes. I don't know if you covered it, but the let bind. The first question is, I guess, the let bindings that you have in that closure that you're basically passing in. That's the equivalent of the thread local storage for that thread. Is that correct?
Yes.
Okay.
So you bring up you reminded me of another thing that I want to discuss. So yes, what you see here is one way of actually passing arguments to threads into its thread local storage. However, as you can see here, this is a bit unwieldy, all right? Because I've essentially created a lambda, an anonymous function, that I tried to, I would feel that would be cleaner to have it as a normal named function. And then we would obviously just call, bt make thread on the named function. But one thing I noticed, and I wasn't sure why, and I want to see if other folks had ideas. When you actually, do the let binding and you have a named function, it doesn't look like the named function's lexical environment is actually grabbing those variables, unless they are global variables. That is, if they were dynamic variables defined with def var or def parameter. One thing I was thinking, and I want to know if this is a good design, I'm not entirely sure, but I'm fairly certain that you can do this one way, is to do something like the following. Of course, we're going to have to start this once we do this, but that's fine. This. So let's go ahead and create a function. Let's say that we had a function called process client. All right. Obviously, they can't take any arguments because it is an actual I don't know. I'm pretty sure from my experiments, I saw an issue with actually. Let me take this guy out. Hold on. Okay. So one thing I will tell you, if you try to have a function with arguments, I did notice that it will complain that a function with arguments is trying to bind it to make threads. So you would have to wrap it around with an anonymous function if you have a function that takes in arguments, and then have it get instantiated inside of a thread that's actually calling the no argument lambda. In this case, let me just put one thing here, and then we get started on our discussion, which is get what's that? That's
So what you're saying is becoming like a kind of a function factory, basically?
Yeah.
Okay.
So here we go. All right. So one thing that I noticed when I did this, okay, is if we call this guy in, sorry.
Can I interrupt you for just a minute?
Yeah, sure.
Is there any particular reason why you're using that string output stream that way?
Oh, I have. I created a make string output stream. When I tried to pass in a worker, I tried to attach a thread number to the worker so I can actually look at it. And I used make string output stream to create that, and get output stream string. Output stream string is what I thought is what I used to actually grab a string from a stream that I populated.
May I simplify that whole process for you a lot?
Sure.
You can format to nil, and format will return the string.
Oh, okay, nice. That's also.
It literally does exactly what you're showing there. It creates a string output stream and then pulls the string out of it.
Excellent. I did not realize that. Thank you. Another thing about format that I just learned today, of the many things I keep learning about format. Oh, jeez. Okay, thank you.
There we go. so much better.
That looks much better.
Okay.
There we go. All right. So now on to what I was going to ask. So originally I had this code the other day when I was trying this out, and I noticed that unless stood out, say, is bound by a def var, and it's a dynamic variable, this closure will not actually pass in the arguments into this function. Okay, so the only way this would work, at least I thought it would work, is you see in this let form inside this function I have how I have this let form. Common Lisp gives you the ability to create essentially I would say you can create a dynamic variable inside this lexical environment.
Don't teach them that. Don't ever use that. Don't ever use a local special declaration. It is a terrible idea, and it leads to spaghetti code.
Would it be better to then create a def var? Because I think that's that's kind of global.
Don't do that either. Okay, here, solution to your problem. Okay.
All right.
The body of process client and an extra lambda.
Process client and an extra lambda that calls it. Okay. Let me see.
No. Just wrap it in a lambda. Have process client return a lambda function.
Oh, got it. All right. So what I had originally. Okay. So I had this guy. When I refactored this, it was already a lambda. I just made it into a named function. Okay.
Yes.
All right.
Yeah, do that.
All right.
Now have process client, the main function, the outer function itself, take a split out.
So, I see.
Yeah.
I see. Okay. You're essentially passing it into a named function with an argument. Okay. So I'm kind of curious now because I didn't see anything about non-use of special or dynamic variables. Could you give me some clarification as to why that would be bad in the case of at least creating arguments for a thread?
Okay, so a couple of things. Just in general, local special variables will drive you insane. In the long run, it gets messy very fast. Secondly, it wouldn't actually solve this problem because the problem you're still facing is that special variables don't get, by default, they don't get copied, like the innermost value doesn't get copied into a new thread by default. The innermost binding on a special does not get copied into a new thread and become an extra binding on that thread. When that thread gets created, it sees the outermost value for that special like any other thread would, because bindings on a special variable are thread local. Bordeaux-threads, I'm pretty sure in BT make thread maybe, or some other part of the API, has a way you can give a list of special variables for which when BT thread gets invoked, it should copy initial bindings.
Yes.
That's it.
Default initial bindings or default special bindings. I wasn't sure which one.
Yeah. So initial bindings, what you want to do is you want to put on that list the names, the symbols, literally the symbols, naming the special variables whose current value you want copied into a new thread. And so another way that you could do this, actually, is you could put standard out into the initial bindings list. Okay. And then just refer to the standard out variable.
So let's see. So let me try this one. So you're saying that we could do it also this way. If I create process client with no arguments.
Yes.
And obviously we don't want to do that.
Really need a paren manipulation library now.
Yeah, what? do not. I know. I need a lot of things to actually clean up my my Lisp environment, but I have yet to. We'd have to sit down and get me set up on that.
We need to do a Space Max walkthrough one of these days. We really do.
We do. I'm not going to disagree with what you just said. We have to. I mean, I would like to move over to Sylvester one of these days. So, if I understood you correctly, if I do stood out.
No. Just pack in star standard out stuff.
Oh, star standard output star. Okay.
Yeah. Now.
In my code, I'm going to have to reference that somehow, don't I?
You need to replace all references to stood out with standard output.
Gotcha.
Or just, to T, for example.
Gotcha. Replace string stood out with T. All right. Okay. So.
And then you remove that let star.
Oh, I have a let star. Yeah, I don't need this anymore. All right. All right. I think so. That's it. All right. Cool. No, wait. That's not it. There we go. That's what I needed. This should work. Undefined. Oh, well, that's because I didn't. No, this one.
Oh, hash quote process line.
Well, I have to do this guy.
Yeah.
Right.
Because you want the function.
Correct. All right. So this should work. All right. This is much cleaner now. This is a good much cleaner. Although I would still prefer leveraging L parallels on this too as well. So, but this certainly will get much farther along than where we were originally at the start of this discussion. Like I said, I'm going to check this in for you guys. I had the original version of this that I demoed it earlier already available. If you guys do a git pull, I will check this new version in too as well, so you can see you could do it before and after.
Can you do one other thing for me?
Yeah, sure.
What's the variable that holds the default value for initial binding? I forget what it's called. You see it in the LDOC for BT make thread.
It's BT default special bindings.
Okay, can you con standard output onto the front of that, or just actually show that at the reference firstly?
Okay, you wanted to see BT default special.
Yeah. Okay, yeah. No, what you want to do is con standard output onto that list.
Oh,
because,
got it.
Yeah, that way, if for whatever reason something else is putting something on there, then you need to quote that symbol.
Oh. I need to quote, you're saying
standard output.
Oh, quote standard output, got it. All right. So, fortunately...
In this case, it won't change anything, but long term, that's the better practice. You want to preserve the stuff that's already on there.
Instead of completely overriding it with your own custom things. Right, that makes sense.
Yes. There may be cases where you do know that you want to completely override it, but this isn't one of those, I don't think.
Right. Well, I don't think we know what originally passed in. I don't know if I can actually print it out. I would be curious as to what is passed in when the thread is actually created. It would be interesting to see. I'm just going to make a note that I'm going to try this too as well later on.
Yeah, you'll probably test that. There's probably a bug in there somewhere.
Yeah, and obviously a test suite needs to be written for this so that I can make sure that what I'm expecting happens. And one thing I'm gonna show to you guys, folks, and I didn't have time to do this this week, was I wanted to add data to Travis so that you guys can see how if you needed to do any sort of data-driven tests inside Travis through Common Lisp, this is what you need to do. Unfortunately, I didn't get a chance to do it because I have school obligations sort of like prevented me from doing it. So I apologize for that. But
quick follow-up question.
Yeah, sure.
Right. So my original question was about local, and so the stuff that in the let binding, or I'm sorry, the let form at the top of the that function is basically thread local essentially for spawn.thread. But according to what Elijah was telling you, so there's basically no way to, or it's not a desired practice at all to want to create a thread local dynamic variable?
No, dynamic variables, so they have a global variable, and then they have a bunch of bindings on them, right? And each binding is more and more local in the dynamic runtime context, right? Dynamic variable bindings are thread local. They just are. And so that way, if one thread, locally binds a dynamic variable, suddenly, sister threads don't see that change, because that would just cause all kinds of chaos. The thing that I was getting worked up about was there's this thing that you can do, which is you can locally declare a variable special, which is effectively making its variable bindings dynamic instead of lexical. It's a bad idea. Don't bother learning it. It just causes spaghetti code. We like the idea of any variable that might have dynamic bindings. It needs to be obvious that's the case everywhere it's used, that it might have dynamic bindings on it. And so we always want those to be marked globally as such, or at least I do. It makes following the code a lot easier. Whereas, while you can, technically speaking, declare a variable, a local variable, as having its bindings be dynamic, anytime elsewhere that you want that variable to be able to see dynamic binding on it, you also have to declare it dynamic special. Technically, the declaration is named special.
Right, and you're saying that's kind of like it's almost a leaky abstraction, because you're telling the people that, oh, by the way, this function call, there are these variables inside these function calls that are dynamic by nature, and I can change them to a particular state. So you're almost telling its internals to the folks outside, which is kind of not good.
It makes following the code a lot more difficult. Dynamic variables in general can make following code a lot more difficult. To use carefully, they tend to make it more readable than less, in my experience. But you can go overboard with them, and then your code just becomes a mess. And the moment you start talking about, non-global special variables, you've gone too far.
I've tried to isolate my discussions for dynamic variables, specifically in this case, which is concurrency, just because I know that that's where I use them at the top level. So I'm treating them like a series of processes, almost independent things. I think that's a good use of them. If that's wrong, please correct me.
No, that's a perfectly good use.
Yeah. So I'm thinking of let's say that you have, I'll give you a container example. Like if you're running like a Docker container or even a process inside Unix, you'd use your shell environment, and you specify shell variables that get inherited when that environment gets spawned. So like when a process gets invoked, it will copy the current shell environment into itself. So when you do a get env or set env, it sets up those environment variables. I treat dynamic variables much in that same approach, but I don't know if that's good or bad. I think that's a good way of handling them, because I'm treating them as separate process variables, and I'm trying to keep them in isolation. But if
it's in the best way, in my opinion. In my experience, it works well enough.
Okay.
I actually had an odd idea for a demo that you might want to try, if you're interested.
All right.
Can you open a scratch buffer real fast?
Yeah, sure. Give me a second here. think I have a scratch buffer already available.
You're in Find File.
Yeah, I'm looking for that. Yeah, there we go.
So it's generally a bad idea, even if you're trying to limit scope. Like, let's say that dynamic variable is only, like, let's say you spawn some threads and then they spawn some threads, and you have like a thread hierarchy, and you only wanted those things to be essentially visible to the second tier threads from the first tier, as if the first tier of threads was essentially the scope that you're trying to kind of limit from there down instead of from global down. Even then,
the second tier threads couldn't even see the first tier thread dynamic bindings unless the first tier thread went out of their way to, say, pass them to the initial bindings of BT make thread.
Right.
Right. And so just making the dynamic variable global doesn't change that access. It doesn't. But what it does do is it means that when you're reading the code, it's obvious that when you see a dynamic variable, that it is a dynamic variable. The earmarks help with that, and then you also know that it will have some global value, and it won't. It makes sure that that way you don't get into weird cases where some places where you see this variable name, it's lexical, and some places where you see it, it's dynamic. Because when you get into that kind of nonsense, your brain starts to explode and melt out your ears and such.
So.
Oh yeah. So my demo idea. Can you create a quick little some global variable, foo, for example?
Okay. The parameter. I guess we'll call one variable 1. Just because I can't think of any name right now. I apologize.
Start at 0, if you don't mind.
What?
Start it at 0, if you don't mind.
Oh, yes.
The
thank you.
Value.
Yes, thank you. Yes.
Set the value at 0.
Oh, you want me to put a value at 0? Okay, got it. Okay.
Yes. And create a function that increments that variable 10 times.
Okay.
And specifically increments it.
Okay. The do times.
A function that does it.
Oh, a function. Okay, got it. With no arguments, I'm guessing. That just simply just does
Correct.
this. Okay. Incf. All right.
Yes, go ahead and compile that in.
What? Oh, wait a second. Did my buffer? Why did that not work? That should have allowed me to pass it into. Weird. It's not passing into my slime bubble for some reason.
You don't have slime mode enabled. Go ahead and run the command slime scratch instead of just scratch.
Oh, slime scratch. Thank you. Didn't realize
Yeah,
that.
that's a better buffer for doing Lisp scratch stuff.
I'm gonna make sure my Emacs. I'm gonna try and see if I can get my Emacs thing to always open up a slime scratch buffer, so I don't have to deal with that. All right. And you want me to call it?
Not yet.
Okay.
So actually, one last thing at the top of that do times there.
Mm-hmm.
Give a third argument to the do times, which will print the value of the variable.
Okay. Do you want me to wait? Is it third argument?
Are you familiar with third argument to do times?
Yeah, I am. I'm looking at an optional do times is result. Okay. I guess.
It's just an expression that gets run after the loop finishes and provides the return value.
Okay, so I guess I will do result.
Yeah, go ahead. Print variable 0.
Okay. Okay, got it. All right. And now you want me to run it?
Sure. Let's just run that for now. We'll see what that does. Okay. Yeah, and now if you look at variable 0, obviously it's been incremented.
Yeah. If we do, hold on. Sorry.
Oh God, you opened the calculator.
Yeah, I didn't mean to. All right, and you'll see that it's incremented, right?
Yep. Yeah. Go ahead and reset it to 0.
Okay. Set F. Okay.
Now run the increment variable function on a secondary thread.
Okay. BT thread.
And go ahead and make the initial binding be standard out, so that we make sure that gets pulled over.
Okay, gotcha. Initial bindings.
No, just standard out. You're good with that for now.
Oh, okay.
Yeah, go ahead and run that.
Standard output is not a type of list. Hold on.
Oh, okay. Interesting.
So I have to do a cons and then do this and then.
And standard output. No. Yeah, actually, I got that a little wrong. I think it's actually an A list of variable value pairs.
Oh, so it's an A list. Okay, so list.
So cons.
Oh, cons. Okay.
It's cons. You need to do both. Sorry.
Okay. List. I don't need to. I don't actually have to do this guy if I'm going to call it list.
Correct. Yes.
Cons. That's what I was looking for, not const. I'm not writing C++ here. All right.
And the second argument, you want the first one to be floating, but not the second one.
Okay. This guy. Okay, got it.
Yeah.
All right.
And that's the actual way you should be using that.
Okay. All right.
Yeah. So you see, it printed the value out. And that actually ran so fast that it finished before it returned.
And if you see it, you'll see that the global variable has been changed yet again.
Yeah. Yeah. Now, go ahead and make that a function. That little expression you put there. Go ahead and make a quick dummy function that does that.
Okay. Go and grab this. Fine. Dummy threads. I'll just say increment threads. And, allow me to generate this multiple times if we need to. All right.
You're way ahead of me.
Hey, I see where you're going with it, so it's.
Yeah. Run. Reset the variable and run it twice.
Okay, and create increment threads. Let's say twice. All right, 2 different threads, right? Okay.
Yep. Yeah. Okay. That's a 9. It doesn't increment enough time. Make it increment like 500 times.
All right.
No, not 500 threads. Go up to the increment variable. Make it increment like 500.
Oh, got it. All right. I see it.
We'll just keep bumping that up until we start seeing collisions. And recompile that.
Yeah. I see it.
Oh, I see. Yeah. Okay.
Okay, got it. All right. And let me reset this variable as well, so it's back at 0. All right. And now, let's do 5 threads and see what happens.
Sure.
Still not. Still 5,000.
Sure. Try that.
All right.
We're sure to see something eventually.
All right. Dang it. It's still really fast. Here, I'm going to do 500,000. I'm going by a factor of... Dang it. Sorry. I'm so used to actually...
Yeah,
all right.
There we go.
Yes.
Much better. Okay. Now, last thing I want you to do, right? Add variable 0 to the list of initial bindings and initialize it with 0.
Got it.
So you want to... No.
Yeah, another cons cell. Got it.
Yeah.
Another cons.
and recompile that. That's weird.
Oh, wait, there we go. I was in. Okay.
And check the global value.
That's right. But that makes sense, though, right? You've essentially, that's the difference between putting it in thread local and
right.
And using
by adding
a global
it to
variable.
initial binding, you created a thread local binding on each of those new threads.
But you could also do the same thing, though, with. So I guess one question I always had is you could certainly do this with a closure too as well, right? I mean, you're creating a lexical environment.
Yeah. You could do it with a closure, but of course then inside the closure you might want to reestablish the dynamic binding anyway, because sometimes you do want it for the dynamic property. You want to, it to go into functions you call and functions they call and such, things like standard output. You'll want to, affect inner functions.
Got it. One thing I wanted to bring up is the reader macro that I saw in the example. So in the cookbook, they suggested that another way of actually leveraging at least standard output is doing something like this. What are your thoughts on that?
Oh dear. Technically, that will work. There's a good chance that
I was reading that this is a security hole when I was reading. I think it was in Let Over Lambda, and to disable this.
Oh yeah. Whenever you call read on untrusted input, you have to disable read eval. You have to.
Okay. So I'm just kind of curious if that's the case, then is this even a good practice?
Yeah, no, it's fine for you to use it in your code.
Okay.
Because you trust your code.
Right.
Your code is trusted input. What you don't trust is when you call read on some file that you don't already know about. So the read eval reader macro, right? It introduces evaluation during parsing, right? And since we use read for also pulling in data and not just code, if you ever use read as like a network protocol, for example, you print and then read on the other side, you need to disable read eval on that when you invoke read to read from that network bucket, right? Because otherwise you've just given the world a REPL.
Right, and you don't want to do that. And that's essentially.
Did you see why read eval does introduce a security hole if you've got untrusted input?
Yes.
Yeah, but for you it's fine. The problem with that particular use of it, and it's not really a problem per se, is that will get you the value of standard output from whenever that code was compiled. Right? On whatever thread that code was compiled on, you'll be capturing that value for standard output.
Right.
And so, while in practice that probably won't be an issue most of the time, it could be surprising every now and then what standard output that captures.
Okay.
Basically the thing is you don't know what thread your code gets compiled on.
No, I understand what you're saying. That makes a lot of sense. I think bottom line is to always just leverage initial bindings to set up your environment when you're creating your threads, just to be on the safe area, regardless if you're using the standard utilities, and try to ignore using reader macros in that case.
Oh, one other thought. That particular, your initial bindings list there, this might be a good use case to use quasi-close or backclose.
Okay. So you're saying use in the initial binding use this.
Yep, and then remove that list call,
Right.
Just a symbol, yep.
Got it.
And then instead of cons, use dot.
The cons, do I need to do anything particular for the cons?
Yeah. Because right now you're quoting that entire.
Oh, right.
list.
So I'm gonna have to do a comma here, right?
No, you don't. Instead, remove the con symbol entirely.
Oh, okay, I got it. Sorry. Okay.
Put a dot between the two things.
Yeah. To make it a dotted pair. Got it. All right.
Yes. And you don't need to quote the first symbol, but you do need to unquote the second one.
And then, don't need to quote this guy, but I need to unquote. In this case, I'm going to have to do a comma, right? I think I have to use
just a comma.
Yeah. I'm quoting it. I just wanted to make sure I got that piece right.
That's perfect.
Okay.
For style reasons, you would leave the comma off on the 0 because that is a constant. But in practice, you'll probably use the comma there more often than not.
So you're saying that even in some cases, you just do that as well.
Yeah, I mean, in this particular case, it would have no effect, but you're probably going to put that comma there more often than you would leave it out. In other uses of initial binding, you're more likely to have that comma there than not. Well, it depends.
So weird seeing backquote outside of a macro.
I mean, backquote is a Lisp template utility.
Yeah.
You know, and the sooner you get used to backquote being a Lisp templating utility, the easier it will be to use in macro.
Gotcha.
Honestly. The better you get used to seeing and reading backquote as just a utility for templating Lisp structures, the easier it will be to use in macro.
Okay. That makes sense.
So guys, I'm sorry, I don't want to. I hate monopolizing the conversation.
No, go ahead.
The second question I had brought this up a couple of months ago, but it, way premature. But maybe now that Elijah's on the phone, he'll have some good input on this. I'm curious about, with all this threading stuff, what is how concerned? I'm assuming probably vary. Do I have to be with like thread safety? Like what library functions or thread safety? Like if I have a hash and I'm doing something, I basically have to lock everything from any kind of standard, any of the standard library stuff.
Okay, so the standard library functions themselves are thread safe. No standard library function you call is going to break because of stuff going on in another thread. They aren't atomic. Well, I guess probably no. They are atomic. What they aren't is, I mean, you have to deal with thread safety concerns anyway. But like if you're doing get hash and put hash, for example, just the get hash or the put hash itself, that is atomic. You're not going to see random nonsense occur because two threads tried to put hash at the same time. One of them will succeed and the other one just won't affect anything. Standard library mutation functions are atomic. Now, of course, functions like destructive functions that do assignments internally, the standard doesn't guarantee always like the order they do the assignments in or anything like that. And so, if you like try to sort a list at the same time on two separate threads, I have no clue what will come out of that.
I'm going to try that now later just to see.
Yeah, but it's going to cause an error. It's not going to crash your list.
Right.
It'll probably give you junk out of the sorting function. It might hang on a poorly implemented list, or depending on exactly what sorting algorithm they use, but I doubt it. More likely, you would just get junk out. But you're not going to encounter cases where you'll corrupt your list by calling standard library functions to two separate threads at the same time.
Okay, so like, is that obviously that thread safety isn't guaranteed by any kind of standard? So is that like mostly like an SBCL thing, or is that?
I can guarantee that on
fiction?
Yeah. So that's something. At the very least, I can personally guarantee that on SBCL, that's the case. It's pretty much impossible to corrupt SBCL by doing stupid multi-threading stuff. SBCL will catch you and throw you into some nice safe debugger environment, unless like you start calling SBCL internal functions and really mucking up stuff. I can't personally guarantee about other lists offhand, but my experience with reading this code and my general intuition about it would be that you shouldn't have to worry about calling things in the CL package specifically. As long as you're staying portable, you shouldn't ever have an issue with multi-threading causing corruption of the image. Now, you make a surprising result,
yeah,
but you won't have to work in the image.
Yeah, that's part of what I'm worried about. You can easily write multi-threaded code, run it like 1,000,000 times, and test it. It looks fine, and maybe something is not thread safe that you think is, and then it goes into production, and the whole thing explodes, and then you spend 2 weeks trying to figure out what the hell happened. So I was wondering if there was maybe any documentation, even just on the SBCL side, that said these functions are thread safe, these aren't. Are there any things that have to be run? I don't know if there's an equivalent of a main thread. I'm assuming not, because there's probably no GUI stuff associated with it where you have to run certain things only on the main thread, or if there's any kind of funny.
Actually, so I've done some work with SDL specifically in Lisp and SDL on Mac. I know, or it might just be OpenGL actually. Really, what I've done more is OpenGL than SDL. In truth. I know on Mac, at least my understanding is that you can only do OpenGL calls from the main thread.
You can only do all drawing stuff on the main thread.
Yeah, okay. So the main thread on every Lisp implementation I've seen is the initial thread, which would be whatever thread the REPL comes up with when you first start the Lisp up. That's at the very least the case on SBCL. I know that for certain. And I know a lot of lists that is the case. When you start your list in something like Swank, oftentimes that will not be on the main thread.
So if you look at BT all threads, you will notice that the Swank server is running, I think, on 2 separate threads. There's one for input and the other one's for caching, but I'm just doing a bthreads all threads to show everyone.
If you don't mind, could you pull up a proper shell and just run a CCL raw on the shell, footload bordeaux-threads and run that?
You want me to run what on the shell?
SBCL.
Okay.
And then BT all threads.
BT all threads. Okay, hold on. I have to first load. It. Give me a second. I'm gonna have to run it. I'm running the wrong one. I have to run Roswell.
Fair enough.
Sorry. Okay. 2L quick load Bordeaux. Okay. BT all threads. All right. You see that's the main thread. That's the only thread that's currently running.
Yeah. SBCL functions like that, unless I think there are ways that you can tell SBCL even in a REPL environment to launch background threads to handle stuff. But regardless, when SBCL starts up and it launches whatever top-level function you've provided, if you saved one, by doing a save list and die. If you specify a top-level function, when that executes, it'll be in the main thread. When SBCL launches, the REPL is on the main thread. I know that much. When you launch in Slime or Sly, best guess. You really have no clue. There are ways that you can make Slime hop over to the main thread, in my understanding. I've seen there's trickery to do that. The simpler thing, though, is to actually launch a Swank server directly using a script. If you really care about threading, you would launch a Swank server directly from inside a list that you start yourself, and then you can control much more directly using Slank's own API for launching and managing the server side that runs inside of your list image, exactly what thread things are happening on. And actually, I know that at least one member of our community who's in charge of Temple, goes by the ID Badgers, he actually, in Temple, he includes a script specifically for launching Temple on OSX, for launching a Slang server on OSX, such that your REPL ends up being the main thread, just to deal with that exact issue. So you can manage it. In SCCL, at least, I don't have a whole lot of experience with other implementations, so I can't really give you a whole lot of advice there. My understanding would be, and my intuition and my experience talking to other people would be that there are ways to manage how threads get launched, how threads get managed, and you know, I can almost guarantee if you start testing a commercial list, there will be extensive documentation on how to deal with that problem.
Yes, I'm almost certain that there's quite a bit of documentation, at least for Allegro. Common Lisp, which I've experienced.
And Lisp work. If you touch a commercial list, it will have documentation out to years. They're very well documented systems. They have to be to cost that much.
Yeah. Right.
And there are ways of dealing with them there as well. I'm certain. I don't know them offhand, but I know that they would exist. I don't. CCL is actually designed for running on OSX. Or at least originally it was. It's now much more cross-platform, and it's sort of held as being, for a while, it was sort of held as being the most cross-platform and free implementation. SCCL is basically caught up in that regard at this point, but the point is, CCL, I'm sure, also has ways of managing your threading situation and specifically dealing with issues involving OSX's, opinions about who's allowed to do graphics calls. So I'm sure that there's documentation there. You could pull up the CCL manual. I'm sure it would have something on that.
The CCL manual, Chapter 7, I'm looking at it right now, has some fairly decent API documentation and some suggestions on if you have older code, but it doesn't really talk about specifics in terms of what functions are thread safe and what's not exactly.
So my point really about the whole thread safe thing is that you're gonna have to unless you're talking about using like CFFI to call something there, or you're directly calling from the level routine, or you're using some really implementation low-level portability library, or you're calling into your implementation internals, I highly doubt any implementation would expose something that breaks in the presence of multi-threading, or that would actually corrupt the image in the presence of multi-threading. And otherwise, they would, I'm certain, function according to the spec, no matter what thread you run them on. The behavior. Even sort, that particular case does bother me. The only ones that I would be worried about are ones that the spec specifically describes as being destructive. So there's things like sort, there's things like in reverse, there's things like oh god, I don't use up a lot of destructive functions.
And concatenation, I think, like in conc.
Right, and concatenate, all of those fun, destructive stuff. And anytime you're talking about a destructive operation, I would probably suspect that you'll get surprising results if you use it on multiple threads. You won't corrupt your image, but you'll probably get some surprising results. And so you'll probably want to lock that if you're doing destructive operations. But if you're doing destructive operations and you're worried about non-local stuff, you're using them wrong. You should never be using a destructive operation on data that could potentially be shared at all anyway.
Right. Okay. Essentially, it sounds like, I mean, right, if you're talking about destructive, destructive operations, I mean, that's basically all thread safety in a nutshell. So,
right.
Basically, it essentially sounds like pretty much nothing is probably thread safe. Like it's okay in the sense that it's not going to like destroy your environment, which is fine. But as far as like your coding goes, you pretty much need to lock everything that is going to be potentially mutated.
If it's going to be shared and it's going to be mutated, it will have to be locked. At least that's I say that it should be locked. If it's functional in that you're doing like a mapping and it's going to generate a new instance, I don't believe it needs to be locked.
Right. No. I mean, that's that's one of the main benefits of doing anything functional is because you're not sharing any kind of state with anybody.
So as long as you stay functional, you're good. But if you really need to share state and it's going to be mutated, you will have to lock it.
You have to lock it. Another option on SBCL in particular, if you're willing to be implementation specific, is SBCL actually has a really nice compare and swap interface.
Right.
So if you're familiar with doing compare and swap based concurrency instead of using lock based concurrency, pretty much just about any place that anything you can set up that's provided by the spec, so like that object swaps, struct swaps, places in spec provided data structures. Pretty much all those places are also doing compare and swap operations, and so you can do thread safe state manipulation that way if that's more your fancy.
Right, and if you want to really get into SBCL specifically too as well, on top of compare and swap, SBCL has an atomics library to create.
Yes. SBCL has a nice atomics library that has some nice thread safe data structures.
Yeah, so you can create some nice lock-free data structures too as well that way. But by doing so, you are restricting yourself to SBCL. You're not. It won't be portable to other Lisps. Or it could be if you find a portability library that shows their way of doing it.
and this, of course, gets us back to L Parallel, actually, because L Parallel is a nice portable library full of just a lot of nice tools for doing concurrency. It has a concurrent map. It has a concurrent reduce. It provides thread pool stuff. It provides a thread safe queue. And just a whole lot of other really useful little things. I think it even has a features API, although I've never used it myself.
I wish we have time for doing this, but we're already hitting over. We're really over time. I do apologize for. I mean, this is a great discussion, but we're kind of out of time for this week. I want to, before I end today's discussion, is to provide an announcement. Starting next week, we're going to be doing an introduction to graphics programming. Michael Fiano will be back, and he's going to be showing us how to do graphics programming using the Sketch library, which is a Common Lisp library that looks kind of like processing, at least from my observation of it. I don't know if it's an exact port, but we're in for a fun time, so I hope all of you can join us for next week on that. Other than that,
I actually had one other thing that I sort of wanted to target was that we mentioned earlier about doing a SpaceMax setup thing. And we may want to start talking about setting aside some time for that. I would be willing to do that sometime in the next couple of weeks. Just taking a session actually and just walking through setting up a nice, fully fleshed out development environment. Personally, I would do a top SpaceMax just because that's what I'm much more familiar with. If we want to talk about other setups, we could go down that road as well. But what would be easiest for me to show off, in the short term would be just walking through, installing, and setting up SpaceMax with the bare minimum of what I consider to be a functional Lisp environment, which is more than just Slime. So I'm just putting it out there.
No, I think it's important. We should certainly sit down, talk about that. Figure out a day that would be great. If it has to be, if we can't get it in with our session, our weekly sessions, we could certainly, you and I can sit down. Let's try and get
at the very least, you know, the two of us should sit down and make sure you have something nicer.
Yeah, exactly. At the very least. But I'll record it just so that other people can watch.
Sure.
But yeah, thanks a lot for joining. I apologize that we went so slightly over, but it was a great discussion on it. And after the graphics introduction, we will come back because I will like to show you guys L Parallel and a couple of interesting libraries I have been finding that came out a few weeks ago dealing with clouds. So stay tuned. But until next time, thanks for joining us. I'll talk to you guys next week.
Thanks.